All right. Hi, everyone. My name is Jose Millan, and we are with Ekaterina, Bastrakova, and Rodney Ledesma, and we are part of the European Masters in Data Mining and Knowledge Management. And we are just going to talk a little bit about our project related with author disambiguation. Why is this important? I mean, in the past years, we've seen that we have many data sources of information about scientific articles, papers. We have many digital libraries. And when we try to search for a specific person, let's say we are trying to search for a John Smith that writes about machine learning, we try to search for his articles, then we find that there is like 10, 100 John Smiths that some writes about biology, some other about math, and the problem appears when we don't know what is the research of the original author we are trying to search. So what we are trying to do with this project is present a solution that takes all that information about the different authors and the different articles, and running a process over that information actually give us the end result, that is the research of a real person. So how does that work? Again, a little bit. So we have an article. An article have multiple signatures. The term signature is pretty important in this project, because a signature is the name of an author that appears in a single article, along with the information of that article. So for example, here will be John Smith with relational, with machine learning, and it will have information about the article, such as the publication year, the subject of the article, the keywords, etc., etc. And as I said, the problem begins when we have multiple articles. So here we'll have an article that written by John Smith, probably an article, and we will also have an article written by John Smith. So what we are doing is creating a process that after running this process, we will have the real cluster of signatures, the set of signatures of each one of the authors, of the real people inside these articles. Okay? So for this presentation, a little bit of an outline. We are just going to talk a little bit about what has been done in the field. We are going to check how we source data for this project, some features that we use for the author disambiguation process, and basically the author disambiguation process or workflow that we propose. And finally, the implementation and the results. So for this, I leave you with Ekaterina, that is going to talk a little bit about the related.
Hi, everyone. So as Jose said, there's been some work in this domain, and the most historical method is the manual disambiguation, which is basically like manually assigning this article is written by me, and this article also. This is hard and time consuming, and also, well, I have to mention the ORCID initiative, which is basically people are trying to give each researcher a unique ID, like a DOI for the articles, but ID for the researcher. That would simplify everything a lot, but right now we have like corpuses of articles which have not the unique ID for the author. So they are automatic methods. They are divided into two big groups. These are author assignment methods, which use which have to know in advance the number of authors in the data, in the articles, number of real authors. And they're basically, the assignment methods are like, we take the article and we, after training, we assign a specific author. So this author is assigned to John Smith. And there's also author grouping methods, which are actually the one we are using, and they're using similarity measures. So looking at how similar are two signatures, trying to predict if two articles are the same or not. Here is a bit about our source data. This is our data model, which we're using. As you can see, there's some information about the articles and some corresponding information about the signatures. It's important to understand that our our system can work with any kind of data from whatever source. Only it has to be has to get through the NATL process in order to feed the model presented here. So we have some article features, some basic features that we took from our data, which is title, publication year, and so on, listed here. But we also did a feature construction, which constructed some complementing features, such that focus name, LDA topic, and ethnicity information, which I'm going to talk a bit in details further. So first one, the focus name. This is maybe the most important feature. This is basically a simplified version of an author's surname. So we take the surnames and we run over the metaphone algorithm, which gives us the results like presented over there. This allows us to avoid many mistakes, to avoid language complexity, transliteration problems, and solves many issues like that. And also, this is important because we have an assumption that real authors' signatures will all be grouped within one focus name. So we are not comparing like Bastrakova and Millan. We're not considering that they can be the same authors. Of course, they can be in some case, but we're not considering that case. And we have an assumption that all the real author will be within one focus name. We had subjects as our input data, subjects for the articles, but they were a bit too specific. There were a lot of subjects, and the subjects were like acoustics or neurology, something like really specific. And so in order to a bit generalize that, we ran topic modeling, specifically Latin directly allocation, over the titles and the keywords of each article, and this is the results we got. These are the 3 most frequent topics with the most frequent terms, and we can assume that the first one is medicine, maybe the second one is networking, and third one looks like biology. And we chose empirically the number of topics of 8 number of topics. And the last feature we constructed was, set of features we constructed was the ethnicity feature. We took surnames of the authors we have, and we took the US Census information of the year 2000, which had surnames with the corresponding ethnicities of all the surnames in the US with a frequency more than 100. So it's a large data set. And we trained several classifiers, and in the end we had like a set of features, each surname belonging or not to the specific ethnicity. And now we're going to speak a bit about similarity features, and I'm leaving you with Jose.
Well, now we have all these features of, as Ekaterina showed you, we have the features of a single signature. Now we go to the next step. We are comparing an author against another author. So for that, we build similarity features comparing every author against each other. For that, we build these features that some are really basic, like we compare the first initial of the first name of author 1 versus author 2, and if they're equal, well, we have that feature. We get the publication year. We get the absolute difference between those the publication of those signatures, and more important than that, we create a distance. We create a similarity feature based on the Jacquard coefficient for the keywords, the reference, the subject, the title, the co-authors, and the ethnicity. So we create different distances based on the article features in order to create these similarity features. And with that information, we can actually talk now about the thing we are proposing, that is the author disambiguation process. So to guide you through the process, we start with the signatures, which contains the article information, basic information like the title, like the subjects, like the different authors' names, etc. As we mentioned, we complement this information with the complementing features, the focus name, LDA topic, and the ethnicities, and we make use of our assumption, as Ekaterina mentioned, saying that a set of signatures the signatures of a real author will belong to the same focus name group. So we divide our data set along with this focus name, and we get different focus name groups. And for each one of those groups, we cross-product all the signatures in order to compare one by one, all the signatures between each other. And there, we actually can include those similarity features. Now, what we do with that? We actually use some machine learning algorithms, and we build different models that are gonna actually tell us if two authors is the probability if two authors belong to the same real, if two signatures belong to the same real author. So for that, we built a SVM model, a logistic regression, a gradient boosting model, and a random forest. And at the end, we compare what are the results with that. And finally, that is what we are looking for. We want to create clusters of the signatures of a real person. So we do hierarchical clustering, and we find the cluster, where a cluster is a set of signatures that belongs to the real person. Now that we have that, we can go and check how did we implement this and what results did we get, and I leave you with Rodney for that.
So for the implementation, we used the best of two worlds, the relational database management system, in our case PostgreSQL, and a statistical software, R. And for our source data, we got a data set from the Web of Science portal that was manually disambiguated, and we got around 1,000 unique signatures. That corresponds to 236 real authors. I'm not going to go in detail of the implementation, but you can go to our repository there. So in order to validate if we did a good work with predicting the real authors, we performed the two-step validation process. So do you remember our workflow? In that step, we compare two signatures to see if they belong to the same author or not. So this is the first validation, and the second validation is in the clustering, and we check if the cluster corresponds to the same author, to a real author. And the results with our 4 models in the first validation. We got that logistic regression, got the best result with an F-score of almost 99%. So it's really, really good. And in the second validation, we performed the 2 methods that are well known and mostly used in this kind of clustering validation, the pairwise and the B3. And as well here, the logistic regression got the best results with almost 85% in the F measure. Another interesting thing is the feature importance of the process. So the most important feature is the distance of the of the referenced journals. As well, we got the initials and then the LDA topic. So the conclusions, in our case, the best model was the logistic regression with very good results. The feature with highest gain is the reference journals, as we can say that authors tend to cite other papers and other works from the same journal as they do. And this could lead to another investigation for community of co-authors. And the initials of the author are really important, as we can suppose. And an interesting thing is that the LDA topic that we created has a better relevance than the subject that the article has. So well, the subject is very, as we said before, is very specific, so we kind of generalized to get a topic that is more relevant. And well, we use two well-known tools in this community, and this process is modular and scalable, so we don't have any problems. And as well, we can calculate the for the future. We can calculate distance with other methods. We can experiment with other algorithms like deep learning, and we can discover new features or use some that we didn't use, for example, the DOI or other co-authors' information. As we saw that the reference journals is really the most important feature, and also well integrate user feedback to improve our solution. Thank you very much.